Good morning, student. Welcome to all online education platform able Eduhub. Students, I am Ashok Kumar. Welcome again and thanks for watching these videos and supporting us. I hope students you are studying and enjoying the study of physics and understand the physics subject. Today we are going to start a very interesting book that is quantum mechanics. Okay, so let's start the book quantum mechanics, and we start a very interesting topic of quantum mechanics, that is what is Compton effect. तो देखो, कॉम्पटन इफेक्ट का जो चैप्टर अपन पढ़ने वाले हैं उसमें सबसे पहले अपन देखेंगे डेफिनेशन ऑफ कॉम्पटन इफेक्ट. Definition of Compton effect. Okay, after then Compton displacement. Compton displacement. Okay, Compton displacement, energy of recoiled electron, and direction of recoil electron. Okay, so we are discussing about these points in this topic, and we will derive the relations for Compton displacement, energy of recoil electron, and direction of recoil electron. Okay, now let's start the topic, and we start with definition of Compton effect. First of all, what is a Compton effect? Compton effect is a scattering phenomena. Compton effect क्या है? Scattering phenomena है. और स्कैटरिंग फिनोमिना जो कॉम्पटन इफेक्ट का होता है उसमें क्या होता है, क्या प्रोसेस होती है. तो अपन किसी वेव को इंसिडेंट करवाते हैं, किसी एक्सरे को इंसिडेंट करवाते हैं, किसमें, किसी रेस्ट इलेक्ट्रॉन पर. ठीक है, और जैसे ही वो रेस्ट इलेक्ट्रॉन पर इंसिडेंट होगा तो फिर वहां से क्या हो जाएगा, स्कैटर्ड हो जाएगा. ठीक है, तो स्कैटरिंग के लिए कोई एंगल बनेगा जिस एंगल पे वो स्कैटर्ड होगा. तो इस सब को समझने के लिए अपन सबसे पहले डायग्राम देख लेते हैं, और डायग्राम डिस्कस करने के बाद में अपन देखेंगे कि उसके डेफिनेशन और डेरिवेशनल पार्ट क्या बनता है. तो लेट्स सी द डायग्राम फॉर Compton effect. So first of all, we consider a rest electron, that is rest electron, and incident a X-ray, that is X-ray, and incident X-ray, it is called incident X-ray. Okay, incident X-ray, and after incident the raised electron is recoiled at angle theta. Okay, that is raised electron which recoiled, so it is called recoiled electron with momentum P is equal to mv. Okay, the momentum of recoil electron is mv, and incident wave will scattered at angle phi, that is phi angle, and it is scattered wave, scattered ray or scattered wave. Okay, initially we know that according to quantum mechanics energy of a wave is h nu. Okay, energy of incident wave E is equal to h nu, and that momentum is P is equal to h nu divided by c. P is equal to h nu divided by c. energy of incident X-ray is equal to h nu, and energy of, sorry, momentum of incident ray is h nu upon c. That's chrome comes from, we know that E is equal to mc square. E is equal to mc square. Then P is equal to mc or mv. It means E divided by c. Okay, and then E is equal to h nu divided by c. The momentum comes from by this relation. The incident wave will collide with rest electron, that is rest electron, and incident X-ray and rest electron are are elastically collide, and means of elastic collide is the incident wave and scattered wave recoiled electron follow the energy conservation and momentum conservation. Okay, now let's see. When incident X-ray collide with rest electron, then some part of energy is transferred to recoiled electron. Some part of energy is transferred to recoil electron, and remaining energy h nu days is transferred to scattered wave. Then momentum P is equal to h nu days upon c. Okay, energy is h nu days and momentum is h nu days upon c. Okay, now we will find out the component of momentum mv and momentum h nu days upon c. So, along to x-axis, the component of h nu days upon c is h nu days upon c cos phi, and component of mv is mv cos theta. Okay, mv is mv cos theta. Now component along to y-axis, then component of p along to y-axis is h nu days upon c sin phi, and that is mv cos theta, sorry, mv sin theta, mv sin theta. Okay, that is the phenomena of, yeah, that is the diagram for Compton effect, in which an incident X-ray collide with rest electron, and after collision the rest electron is recoiled at angle theta, and incident wave is scattered at scattering angle phi. Okay, where phi is scattering angle and theta is recoil angle. Okay, where phi is scattering angle, phi is scattering angle, and theta is recoiled angle, recoil angle. Theta is recoil angle and phi is scattering angle. Clear hai? Now for this diagram we see that some amount of energy of incident ray is transferred to recoil electron, is transferred to recoil electron. It means the energy transferred, the energy transferred to scattered wave is less than compared to incident X-ray. Okay, means E days is less than E. E days is less than E, where E is the energy of an incident X-ray and E days is energy of scattered wave. Means scattered wave have less energy compared to incident X-ray, and we know that E is equal to hc upon lambda. E is equal to hc upon lambda. It means wavelength is inversely proportional to energy. Wavelength is inversely proportional to energy, means if energy is increasing, then wavelength is decreasing. Then wavelength is decreasing. Now let's see, the energy of incident X-ray is higher, means wavelength lambda is less compared to lambda days, where lambda days is wavelength of scattered wave and lambda is वेवलेंथ ऑफ इंसिडेंट वेव. तो अपने पास दो कंडीशंस यहां से निकल रही हैं, लेमडा डेज इज ग्रेटर देन लेमडा एंड ई डेज इज लेस देन ई. मींस इन द फिनोमिना ऑफ कॉम्पटन इफेक्ट, एनर्जी ऑफ स्कैटर्ड वेव इज लेस देन इंसिडेंट वेव and wavelength of scattered wave is greater than wavelength of incident wave. Okay, wavelength of scattered wave is greater than wavelength of incident wave. तो ये दो रिलेशन अपने पास यहां से निकल के आ रहा है. एक रिलेशन ये निकल के आ रहा है कि एनर्जी जो है आफ्टर स्कैटरिंग डिक्रीज हो जाती है और वेवलेंथ जो है वो आफ्टर स्कैटरिंग इंक्रीज हो जाता है. तो जो कॉम्पटन इफेक्ट का फिनोमिना है, वो कॉम्पटन इफेक्ट का फिनोमिना आपको क्या कहेगा, क्या एक्सप्लेन करेगा कि एक ऐसा फिनोमिना है जिसमें अपने पास एनर्जी जो है वो तो डिक्रीज हो जाती है और वेवलेंथ इंक्रीज हो जाता है. ठीक है, तो अब अपन देखते हैं कॉम्पटन इफेक्ट की डेफिनेशन. नाउ लेट्स सी. Compton effect. A phenomena of light in which an energy an energy of scattered an energy of scattered wave is less than incident wave and wavelength of scattered wave is greater than wavelength of incident wave. Wavelength of incident wave called Compton effect. Called Compton effect. Okay, called Compton effect. A phenomena of light in which an energy of scattered wave is less than incident wave energy and wavelength of scattered wave is greater than wavelength of incident wave is called Compton effect, is called Compton effect. ओके, कॉम्पटन इफेक्ट की कंडीशन में क्या होता है कि अपने पास एनर्जी जो है वो स्कैटर्ड के लिए लेस देन हो जाती है और वेवलेंथ जो है वो क्या हो जाता है, ग्रेटर देन हो जाता है। तो ये जो फिनोमिना है, इसी फिनोमिना को क्या कहा जाता है, कॉम्पटन इफेक्ट कहा जाता है। क्या कहा जाता है, कॉम्पटन इफेक्ट कहा जाता है। अब देखो कॉम्पटन इफेक्ट में अपने पास होता क्या है, कॉम्पटन इफेक्ट के केस में इंसिडेंट वेव और रेस्ट इलेक्ट्रॉन के बीच में इलास्टिकली कोलाइजेशन होता है। क्या होता है, इलास्टिक कोलिजन होता है। एंड ड्यू टू इलास्टिक कोलिजन द मोमेंटम एंड एनर्जी रिमेन्स कंजर्व्ड। ओके, तो नाउ लेट्स सी द डेरिवेशन फॉर कॉम्पटन डिस्प्लेसमेंट and definition of Compton displacement. So first of all, Compton displacement. Compton displacement. What is Compton displacement? What is Compton displacement? And Compton displacement is the difference of wavelength for scattered wave to incident wave. Okay, the difference of wavelength for scattered wave to incident wave is called Compton displacement. We know that scattered wave have higher wavelength compared to incident wave, then the changes in wavelength is called Compton displacement. Now definition of Compton displacement: the difference of wavelength for scattered wave to an incident wave is called Compton displacement. Is called Compton displacement. Okay, it's called Compton displacement. Clear है? The difference of wavelength for scattered wave to an incident wave is called Compton displacement. Means del lambda is equal to lambda dash minus lambda is equal to h divided by m naught c 1 minus cos phi. Okay, del lambda is equal to lambda dash minus lambda is equal to h divided by m naught c 1 minus cos phi. That is Compton displacement. That is Compton displacement. Okay, the difference of wavelength for scattered wave to an incident wave, where lambda dash is the wavelength of scattered wave and lambda is the wavelength of incident wave. Okay, where lambda dash is wavelength of scattered wave okay, and lambda is wavelength of incident wave. H is Planck constant. And m naught is rest mass of electron rest mass of an electron. Okay, so that is the Compton displacement, definition of Compton displacement. Okay, now the derivation for Compton displacement. Let's see the derivation for Compton displacement. Derivation for Compton displacement. Compton displacement. Derivation for Compton displacement. Okay. Compton displacement. For derivation of Compton displacement, we are calculating the Compton displacement, a derivation for Compton displacement. And we know that the collision between incident wave and rest mass is elastic collision. And due to an elastic collision, the momentum and energy remains conserved. Okay, so now let's see the collision between rest electron collision between rest electron and an incident wave is elastic. The collision between rest electron and an incident wave is elastic. So momentum and an energy both are conserved. Both are conserved. Okay. Both are conserved. Both are conserved. Okay. Now we applied we applied momentum conservation. Momentum conservation along x-axis. We applied momentum conservation along x-axis. Now let's see momentum along x-axis. Then before the collision, momentum is P is equal to h nu upon c, and after collision h nu upon c cos phi and mv cos theta. Okay, so now momentum along the x-axis before the collision is h nu upon c, and after the collision h nu dash upon c cos phi plus mv cos theta. Okay, next term h nu is equal to h nu dash cos phi plus mvc cos theta, and we have mvc cos theta is equal to h nu minus h nu dash cos phi. That is equation number first. Okay, that is equation number first. MVC cos theta is equal to h nu minus h nu days cos phi. Now, momentum conservation along y axis. Momentum conservation along y axis. Along y axis. Momentum conservation along y axis. एंड y एक्सिस के रेस्पेक्ट में मोमेंटम कंजर्वेशन कैलकुलेट करते हैं. तो लेट्स सी द डायग्राम. बिफोर द कोलिजन इंसिडेंट रे इज अलोंग x एक्सिस. सो बिफोर द कोलिजन momentum along to y axis is 0 and after collision h nu days upon c sin phi on positive y axis and mv sin theta on negative y axis. Okay, means if h nu days upon c sin phi is positive, then mv sin theta is negative. Okay, let's see. Momentum conservation along y axis 0 is equal to, because that is before the collision, h nu days upon c sin phi minus mv sin theta. Okay, by taking solution we have h nu days sin phi is equal to mvc sin theta. Okay, h nu days sin phi is equal to mvc sin theta. This is equation number 2. This is equation number 2. By taking square sum of equation first and second, that is equation second and that is equation first, and if we take square sum, then m square v square c square cos square theta, और सेकेंड टर्म से क्या बन जाएगा, एम स्क्वायर वी स्क्वायर सी स्क्वायर साइन स्क्वायर थीटा. देन साइन स्क्वायर थीटा प्लस कोस स्क्वायर थीटा इज इक्वल टू 1. ओके, सो बाय टेकिंग स्क्वायर सम ऑफ इक्वेशन फर्स्ट and equation second. When we are take square sum of equation first and second, then m square v square c square sin square theta plus cos square theta is equal to h nu minus h nu days cos phi whole square plus h nu days sin phi square. क्लियर है? सोल्व करेंगे तो ये वाली वैल्यू 1 बन जाएगी और उसका होल स्क्वायर सॉल्यूशन कर देते हैं. तो नेक्स्ट टर्म अपने पास बन जाएगा m स्क्वायर v स्क्वायर c स्क्वायर इज इक्वल टू h स्क्वायर न्यू स्क्वायर प्लस h स्क्वायर न्यू डेस स्क्वायर कोस स्क्वायर फाई माइनस 2h स्क्वायर न्यू डेस कोस फाई प्लस h स्क्वायर न्यू डेस स्क्वायर साइन स्क्वायर फाई. देखो h स्क्वायर न्यू डेस स्क्वायर साइन स्क्वायर फाई एंड h स्क्वायर न्यू डेस स्क्वायर कोस स्क्वायर फाई वैल्यू ऐड होके अपने पास इक्वेशन क्या बन जाएगी, m स्क्वायर v स्क्वायर c स्क्वायर इज इक्वल टू h स्क्वायर न्यू स्क्वायर प्लस h स्क्वायर न्यू डेस स्क्वायर माइनस 2h स्क्वायर न्यू डेस कोस फाई equation number third. That is equation number third, m square v square वाली फॉर्म में. Now we applied an energy conservation. Okay, so by an energy conservation, an energy conservation, and by an energy conservation, energy before the collision h nu and energy of mass raised electron is m naught c square according to Einstein equation. Energy of scattered is m h nu days and recoil electron mc square. And next term, h nu minus h nu days plus m naught c square is equal to mc square. By taking square in both sides, by taking square in both साइड, स्क्वायर करेंगे तो इक्वेशन क्या बन जाएगी नेक्स्ट में देखो. When we applied the square for that equation, then m square c की पावर 4 is equal to h square nu square plus h square nu days square minus 2h square nu days. बस थोड़ा सा m square c की पावर 4 is equal to h square nu square plus h square nu days square minus 2h square nu days plus m naught square c power 4 and plus में 2 m naught c square h nu minus nu days. That is equation number 4. Okay, equation third comes from momentum conservation and equation fourth comes from energy conservation. Okay, now from both equations we take the minus. By taking minus, equation 4 from equation third, yeah, equation 4 from equation third, by taking subtraction, या minus, by taking minus equation 3 from equation 4. Okay, so that is equation 4 m square c की power 4 and let's see equation number 3 m square v square c square. Okay, now by taking minus m square c पावर 4 को कॉमन लेते हैं तो 1 माइनस वहां से क्या रह जाएगा v स्क्वायर डिवाइड बाई c स्क्वायर इज इक्वल टू. नाउ लेट्स सी h स्क्वायर न्यू स्क्वायर प्लस h स्क्वायर न्यूडेस स्क्वायर. ओके, h स्क्वायर न्यू स्क्वायर h स्क्वायर न्यूडेस से कैंसिल आउट हो जाएगा, फिर माइनस 2h स्क्वायर न्यू डेस एंड माइनस 2h स्क्वायर न्यू डेस कोस फाइव को अपन क्या लिख सकते हैं, प्लस हो जाएगा माइनस माइनस होके, तो ये बन जाएगा प्लस में 2h स्क्वायर न्यू डेस कोस फाइव प्लस m नॉट स्क्वायर c4 प्लस 2h m नॉट c square new minus new days. Okay, now from relativistic motion, relativistic motion, and relativistic motion gives that m naught is equal to m multiply 1 minus v square upon c square power half. Then m naught square is equal to m square 1 minus v square divided by c square. Okay, then m square 1 minus v square upon c square is equal to m naught square. Okay, now let's see. M naught square C4 is equal to minus 2h स्क्वायर न्यू डेज कॉमन ले लेते हैं अपन 1 माइनस कोस फाइव. देखो ये अपने पास कहां से आया, देखो यहां से मैंने क्या किया 2h स्क्वायर न्यू डेज को कॉमन ले लिया, यहाँ पे भी क्या है 2h स्क्वायर न्यू डेज कोस फाइव है तो 1 माइनस कोस फाइव हो जाएगा, बाकी एज इट इज अपने पास टर्म रह जाएगी तो इसको एज इट इज नोट कर देते हैं. प्लस एम नॉट स्क्वायर सी पावर 4 प्लस 2h एम नॉट सी स्क्वायर न्यू डेज. ओके, नेक्स्ट टर्म एम नॉट सी पावर 4 एंड एम नॉट सी पावर 4 कैंसिल आउट हो जाएगा, माइनस को इधर ले आएंगे तो प्लस बन जाएगा तो 2h स्क्वायर न्यू डेज 1 minus cos phi is equal to 2h m naught c square new days. Now we are calculating new days upon new days is equal to 2h से 2h cancel out हो जाएगा, then h divide by m naught c square and multiplied with 1 minus cos phi. We know that nu is equal to c upon lambda and new days is equal to c upon lambda days. When we put the value of let's see now. We put the value of new and new days, then c divided by lambda minus c divided by lambda days is equal to c square upon lambda days equal to h divided by m naught c 1 minus cos phi. Okay, next term सी स्क्वायर से कैंसिल आउट हो जाएगा, ये सी स्क्वायर चल रहा था तो सी बच जाएगा और ये अपने पास रह जाएगा लैम्डा डेज माइनस लैम्डा इज इक्वल टू एच डिवाइड बाई एम नॉट सी 1 माइनस कोस फाइव. दैट इज कॉल्ड कॉम्पटन डिस्प्लेसमेंट. ओके, दैट इज कॉम्पटन डिस्प्लेसमेंट. Okay, I hope you understood the Compton displacement derivation. Thank you. Best of luck.